Hello, everybody. I'm Glenn from Creative HQ. So I'm going to kind of take a different angle here. I'm going to start with sort of what you might think of as a pitch to a New Zealand corporate. And I'm going to tie this back to investors sort of at the end. So bear with me a little bit there. Okay, so just a little definition here. When we talk about exponential technologies, we're talking about ones like, computers that are doubling on a regular pace, not nice linear things. Just to make it concrete, an example is LiDAR. We call it an exponential technology because of a dramatic change in price over a really short period of time. To tie that together with a little example, so that's a Google car, and in the little dealie on top, they've got about 64 of those LiDAR, and the car uses the massive computing power inside to analyze like 1 million data points a second in order to track every single object within 100 meters and figure out how to drive itself without hitting anything, whether it's moving or not. So it seems a little bit preposterous, just kind of looking at these things in the news and stuff, but actually it's like every major car manufacturer on the planet is now spending a lot of money in the space. And they're not all dorky looking cars. We've got Tesla that's going autonomous, and Audi's doing a lot of investment in the space. So there's a lot of big money in the space. So we're all familiar with Uber. We've read about it. We've taken drives in their cars and stuff. And now they're using Uber as a logistics solution to move stuff, not just people. So we have an example here in the US where some of the biggest retailers are delivering the stuff that you would typically go, to a bricks and mortar store. They're delivering it to you by Uber. So you can be in the park and out of diapers and get on your phone, and the diapers will come, on Uber. You don't have to go to the store. So deliver your stuff now through a logistics platform. So this one, actually, I kind of wish we were doing this here in New Zealand, but anyway, what these guys did is Singapore rewrote their legislation and their regulations and reached out to an MIT autonomous vehicle startup. And they were the first ones to actually do some public trials with autonomous taxis, and they've taken on, by 2018, to have a fleet of autonomous taxis. This is something that I would, love us to be doing, but anyway. So Uber was about a month behind. So the thing I find really interesting about this is that Uber itself says about itself that autonomous version of itself is actually an existential thing. This isn't just interesting for them. If they don't become autonomous Uber, somebody else will do it and they'll be dead. So they haven't even finished disrupting all the taxi companies on the planet, and they're all already on another wave of disrupting themselves. So you're probably not going to have to buy new cars in order to get this stuff. Uber spent a bit under $1 billion buying this outfit, and they retrofit big trucks with autonomous gear. Currently costs about $35,000, but as always in this technology space, it'll probably be 1/10 of that in not very long. And I think they had a recent trial of this where they autonomously, delivered 10,000 cans of beer someplace in Colorado. Okay, so again, it's a little bit hard to believe, but in the combination of autonomous vehicles and Uber-like platforms for doing logistics, you've got this huge alignment of massive companies and massive amount of capital. So you've got Ford lining up with Google, Uber's lined up with Toyota and somebody else, GM with Lyft, which is the number 2 rideshare, Volkswagen with Get, which is like a number 3, Apple putting $1 billion into Didi, Tesla basically, I think they recently said that all of their cars that they're developing now have all the hardware that they need, and they'll just make them autonomous incrementally by doing software update on the cars as they go. And this is just plotting the major deals between major players in the space. So there's so many alignments happening so quickly now you can't really read their icons anymore. So in the UK, they did a similar thing to the US. They changed their regulations, and Amazon went over to the UK to test out last mile delivery by drone instead of doing it in the United States. Again, something I'd love to see us doing. So I'm going to end this little example here. So the idea is, and I originally made this up, but I recently saw that one of the German auto companies has actually just put 500 million into doing this. But that's an autonomous truck by Uber, and it drives into your neighborhood, and the lid opens up, and the drones fly out. One of those drones is going to deliver a package to you, flies around to your back door, puts the package on your back door, takes a photograph of it, texts you that it's done that, along with the photograph of your package on your back door. So in the time that it takes a human to do that, they can basically do 20 times as many packages. So if we just sort of stop there and look at the implications of this, it's like anybody that drives for a living is going to be doing something else. Anybody that sells cars, insures cars, or maintains cars for consumers will probably be doing something else, because consumers probably won't be buying cars. It'll be transportation as a service. And all the downstream ripple effects of that, it's a really massive thing. So the point here really isn't around my believing that this is going to happen or my saying when it's going to happen. It's really around, it's a design pattern. And these patterns are happening, all over the place in lots of different sectors. So the size of the impacts of what people are doing is just, big. So sort of going back to sort of the exponential technology space, we generally tend to, think of that as being just the digital dimension. But one of the things that was really quite mind-boggling, I went over to the NASA campus last year and participated in this 6-day exponential technology program that they run over there on Singularity University. And there are just so many of these amazing technology building blocks, and I'm just going to go through just a couple of them here. But the tools that we have, the blocks that we have to put together as startups now to do amazing things is just actually astonishing. So I'll just give you a really simple example here, because it's not just the Googles and things that can play with these kind of technologies. So Beyond Verbal is one where they listen to your voice and they figure out what you're feeling. And Emotions does the same thing by watching your face or watching video. And Twilio basically lets you build Skype without writing a million lines of code. You write 5,000 lines of code and you've got Skype. So it's a platform for building voice over IP type of applications. So we take those three things together, and we have Skype, where when the guy on the other end is lying, the little Pinocchio icon comes up. So I reckon with that minor little thing, so we did this in our garage, with 2 guys. So with that minor little thing, you've basically completely taken over the voice over IP space. This would be really handy in the American election scene. Imagine, just to put it out there, I know who I'm not voting for. So here's the thing. I mean, this space, and we know a lot more about this than corporates do, but sort of in a corporate context, the space here is that really, there's nothing preposterous. It's almost like if you can think it, there are so many amazing Lego blocks to build with that you can do it. And it doesn't take $1 billion to do it anymore. A startup really can do it. Okay, so there's this layer of all of these amazing exponential technologies that we have as building blocks. And then built on top of that, what some guys did is they basically looked at unicorns and they said, all right, well, let's go dissect 100 of them and figure out what they have in common. And so they created this design pattern where there's these 11 core things. Most unicorns have 4 or more of these. And so kind of like the way we build software by using design patterns so we don't have to reinvent everything every time and we can stand on top of what people already know, there's this design pattern for building a unicorn. Now these are big patterns, so over there in the little experimentation place, that's got methodologies like lean startup methodology, or say design thinking for doing really amazing design work. So these are really big patterns. It takes a couple of hours to sort of go through this, so we're not going to do that today. But the key point here is there's actually a lot of reusable stuff to build yourself a unicorn. All right, so this is kind of the place that we want to take, corporates to when we're having this conversation, which is, look, you're basically a sitting duck. And here's a few little slides to help us understand that. So why does it matter for us in New Zealand? So here's some common examples. We're probably all aware of these. The thing that I find disturbing about this really is that every time one of these comes to New Zealand, we took some profit that used to go around and around in a circle here, and now it goes to San Francisco or New York or wherever. And you can't keep doing that, or otherwise we don't have anything to trade with. So it is a big deal, and these companies are having a big impact on some of our biggest corporates in New Zealand. So I thought I'd take one more swipe. This one's basically, that little box over there is New Zealand exports. On the left are the biggest ones. So I took concentrated milk, aka milk powder, over there on the left. And we'll just run a little example of what exponential technology can do to our #1 export. Okay, these guys basically build milk with no cows. So it tastes like milk, smells like milk, behaves like milk. You can mix it with eggs, you can make an omelet with it, and it works like milk. So if you have cowless milk, there's this long list, sort of the downsides of having of making that product. And you can actually do lots of amazing stuff. Now that you're building the milk not from cows, you can build all kinds of special formulations that are great. We've got a huge population that's lactose sensitive and that sort of stuff. Okay, so how do they do it? Okay, so this goes back to exponential technology. So the way they do that is, so one of those exponential technologies is this thing called synthetic biology. And one of the tools in there is this thing called CRISPR, which essentially lets you copy-paste a gene from one species into another. So what they did is they took the genes out of a cow that are responsible for making the milk protein, and they pasted them into yeast. So now the way, we brew beer using yeast, so now they brew the milk proteins using yeast. So everything else that you need in milk powder is pretty much available off the shelf anyway. You need some sugar or some minerals or stuff like that. You can just buy all that stuff. So now you can take and make your own milk powder. Right. So, so that was, obviously they're going to be a digital company, but they're also standing on top of one of the core exponential technologies. So we can probably imagine what the impact of that is. I'm not up here arguing that we want to drink that kind of milk or that we're in favor of doing it. Really, the point is that whether we like it or not, MoveFree raised, I forget, roughly $200 million to basically run this experiment. So a lot of money behind it. Maybe they'll make it work, maybe they won't. If they don't make it work, somebody else will. We actually need a way that will prosper in the face of other people doing this. Right. So, and it's not just milk. So these guys have $180 million to do a similar thing with beef. So now you've got beef that doesn't come from an animal, and you can put it on the Barbie, and it bleeds like meat does. And it tastes like meat does. Some guys doing it with eggs, people doing it with leather products. So it's not just one isolated incident. Those technologies are being used to go after pretty much all animal products. Okay, so then the other thing, so I'll get to the point here. So we all know this dramatic drop in what it costs to run a startup. Used to be you needed like $5 million to get a go at it. Now you can actually do something interesting with $5,000. Now the interesting thing is, okay, so that all happened because of digital, but a lot of these exponential technologies are not any more expensive. You can get a full-blown synthetic biology lab that your teenager can use, and you can run it in your garage. You can get some pretty interesting 3D printing gear that you can fly in your garage for less than $5,000. So the cost of running, not all of them, but a lot of these new technologies is actually pretty cheap. So here what we've done is plot the arrival rate of unicorns. So 2011 over there, you could see their icons. Over here, you can't read their icons anymore. So from a corporate perspective, the pace at which these guys are arriving is astonishing. So here's the average, or here's plotting some of the ones that have gone really fast. So this is plotting the time they raised their first money, outside money, so they had an exit for $1 billion or more. So somebody broke the 1-year barrier. Okay, so they're actually happening way faster. And then there's this Uber phenomenon where, so they made it work someplace, and they raised enough money to roll it out in parallel in 100 countries, so that nobody else had a chance, to beat them to it. So this sort of takes us to here. So on that red line is kind of the amount of time that it takes from the time where you hear about Uber doing something interesting, and it's across the ocean, so the time it's in your backyard and you're on your back foot. So that time is dramatically dropping. And there are some improvements in the response time of corporates to these sorts of things, but it's not really changing that fast. And I reckon for most of these, we're actually past that trade-off point. So the warning time is actually less than your typical corporate response time. So big doesn't help anymore. Those are on the top. We got the largest 5 companies in the world, and here they are in 2016. There's only one of them that's still left. All the guys at the bottom are people that we would consider unicorns. They're all technology companies. They're all digital companies. So big is no defense. This one, fancy mathematics, but really it's just saying 1/3 of public companies aren't going to be public anymore in 5 years. So companies are dying quickly. All right, so basically we're out talking to corporates, trying to get them interested in participating in Horizon 3 disruptive innovation. So I thought I would just have a look at just a couple examples of some exponential technologies that I think are going to have a really massive change on the pace at which we see some things happening. So just these little blue ones here. So AI is one of the ones that I think is actually going to do some amazing stuff. People have been talking about it forever and ever. There have been lots of promises that it's going to do something interesting before, but we're actually doing some amazing stuff now. So Go is the most complicated game that humans play. It's about 100 times more complicated than chess. And computers aren't presently fast enough to win through brute force. So if you're going to win as a computer, you actually have to be running strategy. So one of the Google companies built this thing called AlphaGo, and they basically annihilate the best humans on the planet at playing Go. Okay, so that's a done deal. So here's another one. So here we've got military combat instructors that fly, combat missions and teach other pilots how to fly combat missions. They, play the game with the computer, and the AI wins every time. Okay, against people that are the best, in the cockpit. And that particular AI runs on a Raspberry Pi, which I forget what it costs these days, but it's less than $50. Okay, so we're not like talking about some massive supercomputer here. So I don't know how many people have seen this Watson thing, but if iPhone is a platform for building apps, Watson is a platform in the cloud. It's a platform for building AI apps. So all the artificial intelligence, machine learning kind of core technologies are already sitting there, so we don't have to write billions of lines of code. We can build reasonably small applications on top that they're calling AI apps. So they're working in lots of areas. I'm going to give you one concrete example. And the lawyers in the room have probably already seen this one. But we got this guy, Ross. Now, he's not really a robot. He's just, a computer program. But you talk to him in natural language, and you explain the parameters of your court case. And he's as good as a law student that's just come out of school at researching the law for you. So he's read every case. He's read all of the law. And based upon all of that, he comes back with an opinion, and all cited and everything else. So he does a huge amount of work for you, does a pretty darn good job of it, and it's just a piece of software. Okay, so it's an app on top of the Watson cloud. Okay, so for me, this is taking to us places like we read about all the science fiction stuff when we were kids, and we're actually delivering that a lot now. So the AI is tireless. It can actually learn most of what it needs to learn on it by itself without us teaching it. They learn by watching us. They learn by competing with us. The AIs actually learn by competing with each other. We can now take multiple AIs that have learned different things, and we can take the best of those learnings and integrate it up in the cloud and create, sort of the next rev AI that's better than any of the individual AIs. So take all of this learning from, say, 1,000 copies of the AI, put it together in one. Unlike us, they can pass it down to the next version. When we pass it down, the next version of us has to start over and learn everything from scratch. So there's a lot of really amazing stuff here. So I think this is going to be big, and there's almost no field that this isn't going to be big in. So obviously, AI is behind, doing robotics. The other thing that I think is going to happen here is that we're going to see AI in the platform space be absolutely massive. So what you need in order to leverage AI is you need a massive amount of transactions that occur, so that you've got the data, you can watch it, and the machine learning algorithms can generate a model where they can do a better job of it than a human does. So the people that are going to win are the ones that build a platform for a very, very narrow domain, and they run it across the entire world, so they own their niche globally. They capture all the transactions. Initially, what they do is they power the platform with humans doing the work, and as the AI gets better and better, you gradually have the AI do more and more of the work. And it's actually not that hard these days. There's platforms for doing human labor. So if you want an army of 100,000 people behind that platform actually doing the work, there's platforms that let you write code to tell the humans what to do. So you can power a platform like this with staff on demand, initially powered by humans. The AI learns how to do it. When it becomes better at the humans than doing a particular task, you switch it over and the AI is doing it. So it'll just be a gradual change in who's doing the work behind the platform. The implication for us here is, we need to own those niches in the world in order to compete in an AI-driven, technology base. If we have just an itsy-bitsy, fraction of the transactions, it'll be hard to compete. Okay, so switching gears to robotics and drones. You guys have probably already seen a whole bunch of this stuff, so I'm actually skipping this one, but this one's going to be big. 3D printing, probably everybody's heard zillions of things there. I was just going to quickly, in less than a minute, go through a couple of examples that maybe you haven't seen, because I think we typically think of 3D printing in plastic, but there's like 750 materials now that you can 3D print in. So you can make things that there's no other way to make it. You don't actually have to own any equipment. In the States, you can go down and you can rent the equipment at tech shop. You can rent the expertise. So if you've got the idea, you don't actually need the technical expertise to do it. This one, this is Carbon 3D. What the the cool things that these guys have done is they've taken 3D printing in the plastics sort of space, and it's so good that you don't need to manufacture it the way you used to. So it's as good as injection molded plastics. So they're filling this massive gap between prototyping and actual manufacturing. So we've 3D printed entire houses out of the local dirt in less than 3 days at 1/10 the cost. These guys, this is the design for 3D printing a freeform house. They haven't printed it yet, but that's what their project is. This is the fastest supercar in the United States. It's a componentized vehicle. It costs 1/50th the amount of money that it takes to do it with conventional production. A lot of the key parts in there are 3D printed. So obviously the shell's 3D printed. The way they do the frame is it's a bunch of carbon fiber tubing that they just buy off the shelf and cut it to length. But the magic around making the monocoque structure is the titanium knuckles that hold it all together. They 3D print the titanium knuckles. No fasteners required. And the engine is mostly off the shelf, but they 3D print the turbocharger, because they could create an airflow 3D printed that there was just simply no other way to manufacture. So up on the top, this is a needle. Up on the top, there's a 3D printed camera. So we're doing stuff, at micro scale. That's a shoe printed out of waste plastic. So cool bit of, materials there. That stuff is actually 3D printed out of filament, where I think it's about 75% of the filament actually comes from agricultural waste. So a nice, recycling kind of solution there. I think the FBI in the United States, they needed to get into somebody's phone. He was dead. They took his fingerprints, they 3D printed his finger and got into his phone. This is one of the most interesting spaces for me. I encountered this down in South Island with one of the researchers that we were working with. And basically what she's doing is 3D printing skin. So people that get diabetes, they get sores on the bottom of their feet, they don't heal, you end up getting your leg cut off. So they analyze your DNA and stuff, and they do a 3D model of your foot. And they 3D print some skin. Takes about a week for the skin to grow. And then they stick it on, and there's no rejection issues or anything like that. So people are talking about 3D printing, organs and stuff eventually. So this will be, obviously, this is massive stuff. And again, that thing I think is 150 grand at the moment. But for the most part, a lot of this stuff is actually really cheap technology. Okay, so going back to synthetic biology, this one's like AI, in my opinion. The impact here is going to be, kind of amazing. We looked at CRISPR. So the other incredible little tool that they've got in this space is they have a thing called a gene drive. And what the gene drive does is when you have a modification that you want to make to the genome, the gene drive lets you quickly install it in an entire population. So you can think of it as like software update for a species. And literally, there's conversations around what happens when we engineer it and there's a bug. What do we do about it? Well, we've got to take the gene drive again, and we've got to quickly make a change, and we've got to reinstall the change in the entire population to fix the engineering problem that we, put out before. So this is something where you can get this equipment for well under $5 grand, runs in your garage. The other amazing thing, which is this iGEM thing, is that there's all these biological parts. So we're just beginning to be able to put these things together the way we do this with software, right? Software is amazing because we have all these components and we figured out how to plug them together, and for the most part, we have standards and stuff that lets us put things together, and they're building this in the synthetic biology place. So somebody can build a little biological component, somebody else can build another one, and they're built in a way that we can actually combine them together into some new species that we're trying to create. So there's that one. All right, so kind of the place that I wanted to take us was that actually, the corporates that we have in New Zealand, there's a huge amount of risk to these kind of developments basically stuffing us. And what are we going to do about it? So I just wanted to, I don't know how much time I got. 9 minutes, yep. I only need like 3 or 4 minutes yet back. So I just wanted to tell you a little bit about what we're doing at Creative HQ. A lot of you probably know Creative HQ. We've been around for a long time. I've only been with Creative HQ for about 1.5 years. Traditionally, we work sort of in the startup community, helping people understand what startups are. Startups organically, arrive at our door, and we take them and help them, get investment ready. We run accelerators like Lightning Lab. So I wanted to tell you about some of the other stuff that we're doing. So we've gone out and we've taken our programs and we've packaged them up so that they work with corporates, so that we're doing corporate acceleration. And this is the 3-horizon model that probably everybody's seen, but generally, corporates like to live over here, where it's incremental improvement. In an example with an automobile company, you'd be making your vehicle, incrementally better every single year. That's Horizon 1. If you rolled the clock back maybe 10 years, you might have been investing in electric vehicles, so that would have been sort of a Horizon 2 thing. If you were a car company in Horizon 3, you'd be investing in something like Uber that's going to destroy you, basically. So we're making corporate acceleration available to New Zealand's large corporates. We've been doing this for about 1 year. We've run 3 of them. We completed our first one with Fonterra. The other 2, I can't tell you who they are. It's early days. I mean, it's pretty exciting for us because it's a really big impact space. All of the problems that we saw in the Fonterra accelerator, for example, were $1 billion problems or more. They've got a lot of resources, they've got a lot of talent, they've got access to big markets, they've got a lot of customers. So, the tools and things available are actually really big, and the problems are really big. We've also done a huge amount of work in sort of being able to track and measure kind of the investability of our startups. So we're trying to create startups that you guys want to invest in. So we started with one of sort of the off-the-shelf investability dashboards that was floating around, and we rebuilt it from the bottom up. There's about 100 sort of evidence-driven points in that now. And we use that to help startups basically create things that investors want to invest in. So one of the things that I'm seeing is this: we've got all of these exponential technology Lego blocks as a foundation. We've got design patterns for building exponential organizations, and we need to be actually building companies that are leveraging more than just digital. Digital's kind of a, you need to be digital just to play these days, but it's not probably the, a lot of these are going to be the core things in the next wave of innovation. So what we've done is we've added both exponential technology sort of metrics and exponential organization design patterns to the dashboard, so that we can measure up companies on that. So this is the last slide. So we've traditionally been, operating in the startup acceleration space. We're on version 3 of this thing that we call the R9 Accelerator. So that's a program with government where we take government agencies, combine them with entrepreneurs, and try to do innovation in a government space. So we're on version 3 of that. A long list of issues to get through there, from getting things like getting government to be willing to take on risk. And then we're working in this corporate acceleration space that I just talked to you about. So for me, this is like really, really exciting, because in the middle here, I kind of think that the next wave of really big innovations, whether it's in healthcare or education or transportation, energy, they're big problems, and startups by themselves probably won't be able to do it. So we probably actually need the intersection of all four of those things in order to take on some really big problems. So it's great to actually be, working, doing acceleration in all three of those dimensions now. And I think for you guys, it creates some really interesting changes in the investment space. So that, the opportunity sizes and the capital that's available to apply to the problems is a lot bigger. In most of these spaces, it's actually the corporates themselves don't have the kind of knowledge and skill and experience that you guys have in running portfolios, and that's what they need to do in the corporate acceleration space. And I think that there'll be a lot more investment capital coming into the space as a result of corporate acceleration. They've got resources, so it might make for some interesting new ways for angel investors and VC investors and corporates to co-invest in opportunities, or to align, those investment pathways. And there'll probably be some other changes. So like in the corporate acceleration space, from the time that we've got an investment-ready deal to the time that we need to get the deal done needs to be like a month. Because otherwise you've taken teams out of the corporate space, you've dialed them up, they've gone out and they've built a business, and then you can't turn them off for 6 months while you're deciding, what you're going to do with them. So the time frame for looking at them, doing DD on them, propping them up with other resources or people that they need in order to make a go at it, and getting the deal over the line, and setting them up on their journey needs to be 30 days or less. So we're going to be doing a lot of work in that space. We've had some experiences where we've taken a corporate team, we've gone out, we've actually built a really interesting business in the space of 8 weeks, and we take it back to the corporate, and they don't actually kind of know what to do with it. So there's a long journey there. And that's what I was referring to before, is there's a huge amount of expertise in the room around, making decisions around which ventures you're going to invest in, how you invest in them, how you think about a high-risk portfolio. And for the most part, the corporates aren't doing that day to day, so it's kind of a thing they're not used to doing. So maybe there's some opportunities for collaboration there. So anyway, we've been doing this for about a year, and we're really super excited about it. There you go.
Thank you so much, Dean. It was wonderful.
Cool.